colleague in the Environmental Health Department, and really a very true friend to our faculty. Dr. Zein, he is currently an associate professor in the University of Sydney, Australia, and he's working on the mathematical modeling of problems of seepage of contaminant migration in soil and groundwater, greenhouse gas emissions from the lithosphere, and waste management decision-making under conditions of uncertainty. And today he's going to discuss with us the results of his research work, which I think is very important and a hot issue actually, the climate change, vulnerability and adaptation.
Thank you.
Please join me in welcoming Dr. Abbas El Zein.
Thanks. Thanks, May. It's a great pleasure to be back, as many of you know. What I want to talk about today, what I thought I'd talk about today, is not so much my own research, specific research in the area. What I was, it all started with a conversation with Iman about climate change. I was having a conversation with Iman, and I was interested in seeing what's being done in Beirut and at AUB specifically in that area. And what I thought I would do is give an overview from my perspective of some of the pertinent research questions that are being asked on climate change, specifically on vulnerability assessment rather than mitigation. And for those of you who don't know the difference, I'm sure most of you do, but for those of you who don't know the difference, I will talk about that in a minute. So this is just a qualification. What I'm trying to do is give an overview about the relevant research question. I thought that would be more useful for the audience this afternoon than actually talking about specific research that I'm doing with my students. This is a scene from Melbourne last. How can we turn off the light a little bit near the whiteboard? The idea is to scare the audience with the fire, and I think with the light, it sort of it dilutes the effect. This is last February 2009. There was a period of particularly strong. It was a heat wave, so high temperatures for a prolonged period of time, and drought, and there was unprecedented forest fires in around Melbourne. So the thing that happened were vast areas were consumed by fire. Some people died in their car while they were trying to run away. So emergency services found a number of cars where people had actually burned in their own cars. And it was unquestionably the worst forest fire in the history of Australia. This is a country, of course, where the ecosystem, a lot of the forests, a lot of the trees and the forests and the forest ecosystems are premised on regular fires. So a lot of these trees need fires to regenerate. So fire is part of the ecosystem of Australia, and yet this was by far worse than anything the country had seen before. So there was 173 individuals died. You can see the statistics. Give you a sense of the surface area. That's about half the size of Lebanon. 4,500 kilometers squared were covered by fire. My niece came to Melbourne over that period, and she landed in just on that week. And initially she thought that's how Melbourne was, and basically just a complete haze. The color of the air in Melbourne was thick brown for a number of weeks, as I understand it. Now, one of the interesting things that came out of this was, obviously there was a threshold of temperature, combination of temperature and drought, which in this case had been exceeded, and which has caused both more intensive fire and more fire that spread much more quickly. One of the interesting things is that people had developed over the years strategies for dealing with fire. And if you happen to have a house which is in a forest area, what you would do, you had to decide. The advice has always been that you had to decide early on, because obviously there's warning, fires don't start everywhere at the same time. Fire starts in some places and they start to spread, and if the temperatures are high, then people get warnings, and you have to, the advice is, normally you have to make a decision. Either you leave, take your belongings, your most precious belonging, and leave, or you decide to stay and protect your house. And the way you protect your house is you make sure there's a clearance between the forest and your house. You make sure you have enough water in your water tanks, and you make sure you keep watering your house to keep it cool. And that strategy works, or has worked, for a number of years. The problem this time was that people who have chosen the second options have paid a very heavy price. Basically, a lot of people died while trying to pursue the second option. What's interesting about the anecdote, it's more than an anecdote, it's stories that have been documented, is that what seems to have happened is that we seem to have crossed a threshold of temperature, of environmental pressure, if you like, where our way of dealing with things has been undermined. The knowledge that we have received over the years in terms of how to deal with these problems suddenly has become perhaps not entirely useless, but certainly it didn't work this time. And if you put yourself in the mind of somebody in 1999 or 2000 who was starting to think about climate change and the effect climate change might have on us, and that person is trying to predict how forest fires are going to evolve, then you could see, and how many people might die as a result of forest fires because of the increase in temperatures. You can see very clearly that that person, in order to make an accurate prediction of what's going on, that person can't afford to just think about the environmental stress. You have to think about also about the way people will react to the environmental stress, and that in itself is not easy to predict. And this is a nice illustration of the complexity of trying to predict how what we call social ecological system, I'm sure there's connotation with eco-health, the idea of combining the environmental, the ecosystem, the natural ecosystems, and the way we interact with them socially. I think it's a story. Now, just to make the story perhaps more interesting, now think about somebody who's trying to predict how we're going to react to forest fires in that area in 2020. That person would have to incorporate, as well as the fact that people have suddenly they found their knowledge of how to deal with the fires change. Presumably, next time there's a fire in Melbourne, people will change their behavior again and will act differently. And if you want to try and develop good adaptation policy, you have to try and predict the way people not just might react or might cope with environmental stress, but the way they might learn from their experiences and the way they might change their behavior again with time. And that's essentially what we mean by adaptation, the way society adapts to these environmental stress. Now, all of this is theoretical, of course. Why would we want to predict that behavior, you might ask? Why waste our time on predicting something that appears to be so unpredictable? Well, there are some very practical questions that policymakers will have to come to terms with, or will have to answer. How do you, if you are responsible for trying to reduce the death toll and the injury toll and the property damage from the next forest fire, what would you do? At what level would you act? Australia has a federal government system, which means there's a three-tier or three levels of government, where there's a federal government, a state government, very similar to the US. I'm sure many of you are familiar with the political system in the US. So where would you act? Is it best to act at a local level? Is it best to act at a state level or a federal level? What would you do? What would be the practical measure? Should you advise everyone to retreat out of forest and not have houses in forests? That would be probably the most radical thing to protect lives. Or should you just improve emergency readiness? Should you buy more ambulances? Should you improve the readiness of forest services? Obviously, there's many things you could do. And the question is, where should you concentrate those resources? These are some very practical questions. And it's because of these practical questions that need to be answered that we need to try and understand how people react to environmental stress. Now, I was talking about forest fire specifically, but you can generalize. You don't have to think of forest fire specifically. And I will give an overview about climate change. I wasn't sure how to pitch, by the way, the talk. I was assuming some of the people in the audience did not know a lot about climate change. I'm sure know a lot about climate change. So I thought I'd give a very brief overview, a little, just down the track about what climate change is. But before I get to that, this is a more general way of asking the question that I've asked about forest fire. What adjustments at different scales and across different economic sectors should we make in order to try and minimize harm from climate change? The questions could be made even more specific. Who is vulnerable? Who is vulnerable to climate change? And how best to characterize? We're talking about future vulnerability, and that adds, we're not talking about today's contemporary vulnerability, we're talking about vulnerability in 10 or 20 years from now. That adds a complexity to the exercise that is quite hard to cope with. And then, even when you've characterized vulnerability, then the question is, even if you've come up with a characterization of vulnerability that you're happy with, then what do you do with it? How do you translate this assessment of vulnerability into actual adaptation measures? This is part of the answer, but by no means the full answer about what to do actually about the problem. Now, this is the outline of the talk. I'm going to give briefly just an overview of the greenhouse effect and climate change, talk about some of the questions being asked. Some of them are theoretical, but all of them have some very strong practical consequences in vulnerability research. And then I want to talk about one particular project that was conducted to assess vulnerability in Sydney, so that I wanted to give you a sense of what this kind of research, what it means in practice. How do actually people go about translating all this research into measures of vulnerability that could be used by policymakers? So I wanted to give you a flavor of that by looking at a case, at a study that was done in Sydney. And then when it comes to Beirut, there's many people in the audience who know far more than I do about climate change in Lebanon and about vulnerability and adaptation in Beirut. So what I'm hoping to do is to raise some questions. As an insider, outsider, I wouldn't say I'm an outsider completely because I've done some research related to climate change in Lebanon, but I've certainly haven't been keeping up about what's going on in Lebanon in the last few years. So what I want to do is raise some questions that from, on the inside and the outside, as an observer, I thought were interesting, and it would be very interesting to see what the audience, what kind of answer the audience bring to them. How many people feel that they need an introduction about greenhouse effect and climate change? Just wondering whether I should skip. Okay, great, thanks. That makes it easier. One thing a lot of people forget is that the greenhouse effect is a natural phenomenon without which we can't live on Earth. If there was no greenhouse effect, when you hear people saying we need to combat the greenhouse effect, it just doesn't make sense. The greenhouse effect is part of the energy budget of the Earth, and essentially the sun emits its ultraviolet radiation, which heats up the Earth. The Earth, in reaction, when it gets heated, emits back a lower quality kind of radiation, radiation that carries less energy, and that radiation is infrared. Now, if there was no greenhouse effect, and you write the balance, the thermodynamic equation balance between the amount of energy that is coming to the Earth, that is emitted by the sun, some of which is reflected back to space, but some of which is absorbed by the Earth, heats up the Earth, which then emits, because it's got heated up, it emits infrared radiation, which is lower quality kind of radiation. When that happens, if you don't include the greenhouse effect and you calculate the average temperature on Earth, if we had no greenhouse effect, the average temperature would be minus 15 degrees Celsius, or minus 19 degrees Celsius. Which is obviously not the average temperature that we have. And obviously the life as we know it depends on having average temperatures that are much higher. It is the greenhouse effect that makes average temperature the 15 degrees Celsius that they are. Now, what is the greenhouse effect? It's the ability of some trace gases in the lower atmosphere, the troposphere, to let through ultraviolet radiation that is arriving from the sun, but to capture some of the infrared radiation that is being emitted by the Earth, which means a lot of the energy that would have otherwise escaped into outer space is kept in the atmosphere. And therefore, we have the greenhouse effect. The problem with climate change is that we've been emitting those greenhouse effects, because those greenhouse gases, far more in the Industrial Revolution, simply because they are the byproduct mostly of the burning of fossil fuel, not exclusively. There's a lot of other processes that emit greenhouse effect that are not energy related, but mostly because when you drive your car and you're burning gasoline, a lot of the gas that comes out of your exhaust is carbon dioxide, and therefore we've been building up carbon dioxide, methane, nitrous oxide, and so on in the atmosphere. Now, there's therefore a surplus energy in the troposphere. There's more energy in the troposphere than there used to be. And what is the climate system? The climate system, the reason why we have winds and the oceans move around and there's rain, is because the Earth gets heated differentially. The equator gets a lot more heat, a lot more energy from the sun than other parts of the Earth. And the fact that we have differential energy means the Earth needs to redistribute that energy from areas where you're getting a lot of energy to areas where you're getting lower energy. And that's what creates the climate system. And therefore, it's only natural that if you have a surplus of energy in the troposphere, the climate system needs to react to this. You're injecting more energy in the atmosphere of the Earth, and therefore there needs to be a reaction by the climate system. And this is what we mean by anthropogenic climate change, which is climate change caused by humans, as opposed to natural climate change, which is climate change which there's natural variability in the climate that humans are not responsible for. I will skip quickly over, I think I'm running quickly out of time. I will skip over some of the physics of that. Very briefly, people looking, if you look at one great way of finding out what scientists are doing in terms of climate change is to look at the way the IPCC, the International Panel on Climate Change, divides up its work. And you can see that they divide up their work in terms of working groups. Some of them are looking at detection, so people are looking at the scientific literature, which is trying to look at indicators of temperature, rainfall, and so on, to see whether climate is actually changing. But even if climate is changing, that's not enough to say that we are causing the change. And that's what people working on attribution are working on, trying to see whether any changes we see in the climate can be attributed to emissions of greenhouse gases. Then there's people looking at what the impacts are likely to be, what we can do to reduce climate change, and finally, there has been almost a consensus among scientists that it's a bit too late to try and reverse climate change completely, and therefore there's a sense in which we need to adapt to at least some climate change. And therefore the question is, how do we adapt to climate change, at least that climate change that we can't reverse? Now, I will come back to this, but before I come back to this, I want to one thing I want to highlight is that the concept of vulnerability is not new to climate change, and I'm sure many of people in the audience, especially people who have worked on poverty, know that. The concept of vulnerability has existed prior to climate change. People have thought about why are some people more vulnerable to famine than others? Why are some people more vulnerable to earthquakes than others? So the concept of vulnerability predates climate change. And there's two theories of environmental resources or environmental risks that seem to have existed in the literature. One is based on a theory, entitlement theory, and essentially this has arisen as a result of people working on famine. And one interesting observation about famine is that a lot of famines are not actually due to overall shortages of food. The famous Irish famine of 1945, while people were dying from hunger, food was being exported from Ireland to Britain. Likewise, there were famines in Ethiopia in the 70s, where food was being taken from the area where there was famine and being sold in Addis Ababa because it fetched more money. And that theory basically highlights the fact that it's not so much to do with the environmental stress why we have famine, it's more to do with the way we decide to divide our entitlements, how society gives rights to some and not to others. Now, of course, when it comes to natural hazards, we think about vulnerability to earthquake, you need more than that. The environmental stress is obviously plays an important role. And this is where people working on international hazards have come up with some theories to explain environmental stress and the vulnerability of people to to environmental stress. Now, the thing about what climate change has brought into the picture in terms of research on vulnerability is that it's quite a different kind of natural hazard. If you think in your mind about climate change and an earthquake, for example, climate change, the impact of climate change are continuous, whereas an earthquake is an event that happens at a point in time. There's multiple manifestations of climate change, there's multiple impacts, its scope is global, and it operates at different scales. It can affect the way we distribute our water, the way we manage stormwater, and so on and so forth. So that presents challenges to people doing research on vulnerability specifically to climate change. And the objective of that research is to quantify it at a given scale. And what I mean by scale is you could be the water utility responsible, for example, for distributing water to the residents of Beirut, and you might ask a question, how vulnerable is my water distribution network to changes in temperature and in rainfall pattern? That's one scale. You could be, on the other hand, one municipality, which is asking, could be a coastal municipality, which is asking itself, if the sea levels are rising, what does it mean for all those houses that are by the sea? That's a different scale. You could be a national government that is asking, what kind of policies should I enact to deal with climate change? That's yet another scale. So this is what is meant by scales. And the idea, the objective of vulnerability is to quantify vulnerability at a certain scale, but also to qualify the connections to other scales. If you're a municipality worried about various aspects of climate change, you can't afford to ignore the fact that although you might have some power over what happens in your municipality as the mayor, but still you need to talk to the water utility, which is responsible for the water distribution network. So there's obviously interaction between all of those scales. Now, what I want to do, this is just a quick background of the questions that are being asked in vulnerability research. What I want to do now, so that the talk doesn't stay theoretical, is to give you a little bit of a flavor of what some answers to these questions look like. And this is in reference to a particular project, not my project, a particular project that was conducted in Sydney to quantify. So people just ask the question. Now, they've selected 15 municipalities, which covered most of the part of Sydney that is adjacent to the coastline. And they wanted to know which of these municipalities should they be worried about. So which have more vulnerability than others. What I want to show you is how they went about doing that exercise. Now, first, very briefly, Australia, the projected impacts in Australia are more heat waves, fewer frosts, an average of anything between 0.4 and 2 degrees Celsius by 2030, rising sea levels. The irony, of course, is that we're going to get less rainfall in areas that are already under drought and more rainfall in areas that suffer from storms. This is just a reminder of a map of Australia. Most of the population lives mostly around the east coast, some around the west coast in Perth, and a smaller population around Darwin. And you get a sense of the drought in the city, in the country, by looking. These are the green area, and the interior of Australia is very dry. This arrow shows you the size, about 200 kilometers, just to give you a sense of the size. So it's roughly the length of the Lebanese coastline, which is 220 kilometers. So just to give you a sense of the size. Now, there's some, you can see already trends in mean temperatures between, this is not projections, this is what's happened between 1970 and 2009. There's significant increases in temperature. And this is what I was telling you about earlier, the trend in annual total rainfall. there's decline around this area. The tropical north up there, as you move up, you're getting closer to the tropics. There's been an increase in rainfall. Now, this is the model that was used by the people studying Sydney, the model for vulnerability that was used by people assessing vulnerability. And it's very much in line with the model recommended by the IPCC. The idea here is that vulnerability depends on 3 dimensions: exposure, sensitivity, and adaptive capacity. I'm sure many of you are familiar with that, but to tell you more about what we mean, if we take the case of forest fires, because we talked about forest fires, you might define your system as the communities living in or adjacent to the forest. The valued attribute that you're trying to protect in this case is the population health and the property. The exposure in this case, these communities are exposed to increases in temperature and frequency of heat waves and droughts. Now, how sensitive these communities are to this increase in terms of these valued attributes in relation to forest fire depends on how much forested area there is and how much population there is living in this forested area. So if you take 2 communities exposed to exactly the same increases in temperature and frequency of heat waves, if one has less forest than the other, then obviously one is less sensitive to this environmental stress than the other. But then, obviously, what complicates the picture far more is even if you take 2 communities which are exposed to exactly the same environmental stress, exactly the same amount of temperature increases, exactly the same amount of forest fire, it's a forestry, exactly the same amount of density of housing in forested areas. One is got a municipality which is very rich and has the ability to take measures to cope with the fires, and the other is not, then obviously one is going to be more vulnerable than the other. So that's the idea behind the model. And the exercise in establishing vulnerability is very much, at this stage, it's pretty crude, it's very much an exercise in trying to see which part of Sydney have a combination of high exposure, high sensitivity, and high adaptive capacity, rather than trying to understand more mechanistically the relationships between exposure, sensitivity, and adaptive capacity. We're not at that stage yet. There's a lot of research trying to come up with more sophisticated quantification of vulnerability, but we're not at a stage yet where we could say this is the relation, the mathematical relationship for a particular hazard between, in climate change, between exposure, sensitivity, and adaptive capacity that we could apply. At this stage, what we're talking about is an exercise in identifying those areas that have a combination of high exposure, high high exposure, high sensitivity, and high low adaptive capacity. Now, the 5 impacts considered in the study, in the Sydney study, was extreme heat, extreme rainfall, sea level rise, forest fires, and natural ecosystems, those suburbs that still have, that are adjacent to national parks, that still have precious or valuable fauna and flora that needs to be protected, that might be affected by some of the manifestations of climate change. I need to talk to you just very quickly about heat waves, because I'm going to, just to illustrate how the study was done, I'm going to focus on heat waves, because I can't talk about all of them. And I know most about heat waves too. One thing about heat waves is don't underestimate how much they can kill. I know we are used to heat waves in Lebanon and the Middle East, but they're real killers. And one great example is what happened in 2003, when within a few weeks, 35,000 people died in Europe, 15,000 in France alone. I've done research while I was at FHS on heat, on the relationship between mortality and temperature in Lebanon. I have some idea about the relationship between those 2 variables, but I still don't know, and I don't know whether people do. Maybe some people do. To what extent heat waves are an issue in Lebanon? I think it's very hard to tell without much more systematic data. Now, the literature on heat stress and death from heat is vast, and we know a lot about who is at risk from heat. And this is a selection of typical population that the literature has shown in many cities over the world, has shown over and over again, are vulnerable to heat stress. In terms of lower socioeconomic neighborhood, that's a little bit of a harder one. There's some studies have found a strong correlation with coming from a low socioeconomic ground, as in between being vulnerable to heat stress or to death from heat waves, and on the one hand, and coming from a low socioeconomic background. Some studies haven't. The picture is a little bit more mixed, and you can imagine some of the confounders involved in this. Now, the thing about heat waves as well about heat stress is that it's not just heat waves that kill more people. It is also the fact that there is a relationship. If you count the number of people who die every day in a city and you plot it against average daily temperature in all cities in the world that were studied, I'm not aware of any study which didn't find this kind of curve. Now, these curves could change. Could be, instead of being a curve like this, it could be the slope could be steeper here, it could be steeper there, it could be a V shape, it could be a U shape, but it's very much a variation on this kind of curve. So we know as temperatures increase because of climate change, more people are likely to die in winter, even if there's not a heat wave, and less people are likely to die more people are likely to die in summer, and less people are likely to die in winter. Now, the way the study was done, and I'm getting close to the end. The way the study has been done is that each component, exposure, sensitivity, and adaptivity, and adaptive capacity, the researchers came up with a set of indicators that reflects each of these. For example, I will show you a list of these exposures, particularly for heat waves. But they've done that not just for heat stress, but for the 5 impacts considered. For heat, for example, for extreme heat, they came up with 7 exposure indicators, 5 sensitivity indicators, and 12 adaptive capacity indicators. They turned these into vulnerability scores. So the scale started off, for example, being degrees Celsius, and they turned that into a vulnerability score. So A as exposed to high temperatures had a high vulnerability score, and A exposed to lower temperatures had a lower vulnerability score. They added the score for each. So 225 are the 3 components, the 5 impacts, and the 15 municipalities that were considered. So they came up with 225 scores. They rescaled to a score of 1 and 9, and they added the weighted score across 3 components and rescaled it to come up with vulnerability map. I will come back to this because that's one of the big weaknesses in the project.
You're mixing all the elements of climate change, all the different.
Yeah, not mixing. Yeah, well, when you're adding, you are absolutely, and that's a big weakness. So what you're saying in essence is that, I mean, I'll show you. They didn't quite do that. I will show you the table that they use. But what they've done is they basically, but if you mix them, if you just add them up, what you're saying is the score that I've come up with for heat waves is equivalent to the score that I've come up with for water. And who knows? It may be that heat waves are going to kill a lot more than water, or vice versa. And this is because we don't quite know yet the mechanics of these problems sufficiently to be able to quantify them in a more reasonable way. But the interesting thing is, yes.
For clarity purposes, the score that has been weighted later on, 1 to 9, includes all the indicators, the scale.
Yeah. So what they've done is they've started off with they've taken exposure. Yeah. Take heat. I think heat is a good example because I've got the details there. So they said, if I take heat, I take exposure first. I've come up with 7 exposure indicators. Let me show you what they are. So these are the indicators for heat, for exposure. They looked at the present average January maximum temperature for each of these municipalities. They looked at the projected change as well, not just today's change. Remember, we're interested in future vulnerability. They looked at land cover, population density, road density. That's for exposure. In essence, to say, well, by how much is a temperature likely to increase? How strong is the, I didn't talk about urban heat island effect, urban heat island effect, but I'm sure many of you know what that is. The fact that when we live in cities, we have warmer atmospheres in cities. So they tried to incorporate that in the measurements. When we look at the sensitivity, its sensitivity depends on to what extent we have vulnerable, the proportion of vulnerable populations in each municipality, but then the adaptive capacity also, the ability, this is mostly socioeconomic. The assumption is the higher the socioeconomic capacity of the municipality, the more adaptive capacity it has. Now, to go back, this is just to make concrete some of these indicators. So what they've done is, they've taken, for heat, they've taken the 7 exposure indicators and they've turned each indicator separately into a score from 1 to 5. Because they're different scales. You can't add up land cover to temperature. So you turn every one of them into a vulnerability scale and then they add them up. And this is where one of the weaknesses is. Then they added up all of these to come up. So now they've come up with one exposure vulnerability indicator because they've added up all the indicators for exposure. And then they added up the indicators from each component. So you've got exposure, you've got sensitivity, and you've got adaptive capacity. Those were added up, but those were weighed, and I'll show you the weighing that was used in a minute, to come up with a vulnerability indicator that combine all 3 dimensions, exposure, sensitivity, and adaptive capacity, to heat in each municipality. And then a further step, now you need to combine all 5 impacts. Again, there was another level at which these were added. So you could see the exercise is not really about adding. The exercise is about doing that, trying to see which of these municipalities have a coincidence of high vulnerability to a number of impacts because of high exposure, high sensitivity, and high adaptive capacity. And in that sense, they've succeeded. They've identified areas where this happens. However, of course, the methodology leaves much to be desired. The interesting thing is what they've done, aware that there's a subjective component of vulnerability. Part of being vulnerable is feeling that you're vulnerable. So what they've done is they went and talked to them separately. They went and talked to each municipality, stakeholders in the municipality, and asked them whether they felt vulnerable on each of these counts, and then went a step further and modified the vulnerability indicators. I don't know how they've done that particular one, whether they've added them up or multiplied them, and came up with a final vulnerability indicator, which includes both that top-down approach and that subjective approach, well, not subjective, but the stakeholders' perception of vulnerability. Interestingly, heat waves is the one area where they found a big mismatch between what they studied, what they found, what their analysis showed them, and what different municipalities thought about whether they're vulnerable or not. Whereas with forest fire, there was much better coincidence. There was a table where the correlation between the stakeholders' opinion and the analysis, top-down analysis, was something like 0.05. R squared was 0.05 for heat waves and about 0.7 for forest fire. These were the 2 extremes. So there was interesting result there. Now, I know I'm running out of time. Quickly, this is a table that they've used to multiply, and there's a whole rationale for it. For example, adaptive capacity, they're aware that being rich isn't enough to deal with climate change, because that's essentially what they're doing with the adaptive capacity, is if you come from a high socioeconomic background as a municipality, then you've got high adaptive capacity. So they gave it lower weight because they know that adaptive capacity doesn't necessarily mean adaptation, and that's an interesting distinction too. We're talking here about adaptive capacity, we're not talking about actual adaptation. In fact, if one of these municipalities had a heat warning system and was doing fantastic things about heat to try and prevent heat death, it wouldn't show on these indicators. As you can see, because these indicators are all socioeconomic indicators. It's because it's about adaptive capacity, not about actual adaptation. And these are all, I'm mentioning all of these things because they really point us to research that is being done, to questions that are being asked about how we go about quantifying vulnerability. Now, these are the kind of maps that they came up with. There's an area called Rockdale, incidentally, with a high proportion of Lebanese migrant living in it. I don't think we are causing the high vulnerability, and you can see one of the indicators is the proportion of people from a non-English speaking background. So you can see that it's not entirely coincidental, because that's used as an indicator of lower socioeconomic background. In terms of not just the intellectual labor, but in terms of getting data from different sources that is tailored to different geographical scales, making it match together. It was quite a big project, and it was the first to be done in Australia, and it's been done elsewhere. This is the net vulnerability, and this is, for example, the equivalent map for Norway. I think Norway was done a bit earlier. This report was released in 2008 in Australia. I think in Norway it's probably back in 2005. This is the kind of work that is being done on vulnerability. In this case, I think one of these maps is about agriculture in the agriculture sector rather than municipal sector, and for exposure and adaptive capacity separately. Now, I won't spend a lot of time on this. I have already pointed many of the limitations of the assessment. But one that I haven't pointed, even if you were able to do more sophisticated quantification, which obviously the researchers weren't in this case, but even if they were, we know that the data that we get, even the socioeconomic data that we get from databases, there's a level of uncertainty in it. And when you combine all these uncertainties, should we have a more stochastic approach to the problem? That is, should our input be, rather than being a single indicator, being a range, an indicator with an average a distribution around a mean? That's certainly one thing that I've got a new PhD student that's working on in this area, trying to have a more stochastic approach to try and incorporate uncertainty in these work. I talked about the arbitrary summation, and the authors themselves had this quote in the report, highlighting that this is a good example. How does one balance the effects of climate change on ecosystem resilience against effects on flood damages? And you could pick any other two impacts to make the point. Another interesting thing about adaptation, I think that brings up a wider point, that's an interesting point, because in the IPCC report, there's often the assumption that developing countries are more vulnerable to climate change. And you could see there's a lot of basis for that. But some authors have pointed out that might not be true. In some cases, it might actually be the opposite. And there's a great example from Konzo people in southern Ethiopia, where apparently they've developed over hundreds of years this ability, when they have a drought and famine, to go and eat some of the wild flora, I beg your pardon, some of the wild flora that is available, which they use only in times of stress. That is a form of adaptive capacity that societies which have not been subjected to such a stress would not have developed. And that which societies that have been living close to extreme stress will have developed. I'm thinking, when you think about heat stress in Lebanon, for example, one interesting point is that a lot of the research has found a strong correlation between death from heat-related events and social capital. For example, people living on their own, over 65, living on their own. If there's a heat wave, you're in Chicago, you live on your own, you're over 65, you've got a cardiovascular disease, and you live at the top floor of an apartment block, don't bother. Essentially, you're a very high risk factor. And that's to do, living on your own is to do with your social capital. One interesting question, for example, and I was going to get that when I talk about Beirut, which I'm getting to now, is to what extent the fact that we I mean, you know more than I do. I'm assuming, maybe it's a big assumption, that a lot of our communities, even our poor community, may have higher social capital than the equivalent poor community in Chicago. Now, will that make our vulnerability to heat waves smaller? I don't know. But I think they're questions that are worth asking, rather than always assuming that because we're in the developing world, it means we are more vulnerable to climate change. I won't go into this. I'm running out of time. I was going to talk about some of the problems in terms of now moving from vulnerability to adaptation. There's a whole issues about equity and legitimacy. I'd be happy to talk about that in question times. As I said, I made sure I'm adding a lot of question marks when I talk about when I thought about adaptation in Beirut, and I don't pretend that it's in any way deep thought, but obviously there's a big problem with when you try and think, can we apply this approach, if we want to apply this approach to that was applied in Norway and in Australia to our cities here. Obviously the big problem that we have is that, well, one problem is that our data collection and analysis infrastructure is not nearly as sophisticated as it is in those countries. But then, even if it was, then let's say we've got that data, then what do we do with it? Our risk management infrastructure is not all that sophisticated. Let's say I can give you, I'm a magician, and I can now give you a map of vulnerability in Beirut of different municipalities, and you know, I assure you that it's very accurate and so on. Well, what do we do then? If we don't have a risk management infrastructure already, then what do we do with it? One interesting example is that it's not as though institutions and municipalities in the West or in the countries that I know of are expending a huge amount of resources on dealing with climate change adaptation. What they're doing is they're mobilizing their existing risk management infrastructure to try and make some assessments and decide whether it's worth expending resources. It's not as though they've suddenly decided this is such an important problem, we need to do something about it. But having the overhead in doing those extra analyses is not so high because that structure is already there. So the question, of course, from our point of view in Lebanon is it worth it? Obviously, we've got other priorities. And I don't know how you approach this. I don't know how you can begin to answer those questions. I mean, I will offer in the next slide, which is the last slide, I will offer some possible ways, and it's very much by way of suggestions rather than now, this question themselves are very much the same. By the way, even if we came up, there's even a question mark about whether we should do municipal vulnerability. The reason why we do municipal vulnerability maps is that there's such a thing as a municipality, as an empowered institution called the municipality in Sydney, which if you give that, in theory, if you give that municipality this information, it can do something about it because it's got resources, it's got power. Well, if our municipalities aren't empowered, then maybe we shouldn't do those. Maybe there are other smarter things to do in terms of assessing vulnerability, in terms of trying to point out. Because what we're trying to find out in the end is who are the vulnerable groups. Maybe we can identify them not by doing a municipal map. Maybe there are other ways of identifying these vulnerable groups and doing something about it. So all of these are questions that need to be asked when you're moving to a context like Beirut. This is my last slide, and one of the questions that one thing we could do, there's a lot. One interesting thing that's coming up with this kind of research is one particular paper in Norway where the authors are arguing that these top-down approaches, they're great, they give out those maps, but in the end, you need to combine it with a bottom-up approach where you go to the stakeholders and try and go from below and try and see what the perception of vulnerability is, because there's local knowledge that needs to be tapped into. And their idea was that to start off with these vulnerability maps, but then whatever you find, like the Rockdale, the red areas, then you go and do something where you're trying to quantify by talking to the stakeholders. And in fact, that's what they're doing now in Sydney. Now, this is in a sense good news to a place like us, which lacks the you know, a sophisticated, or which lacks a functioning data collection and analysis infrastructure. Maybe what we should do is go directly and tap into the local knowledge of the population about heat waves. maybe we can't afford the luxury. Obviously, the first thing we need, in theory, we need to ask, are heat waves a problem? I don't know how we can answer that, but maybe we can start by trying to find out how people react to heat waves. So we can set up research team that are ready to intervene in case of a heat wave, to go and talk to people, to try and understand more about how people deal with heat waves. Whether, for example, the question about social capital, you can answer those questions with qualitative research about whether social capital does improve your resilience in the case of heat waves. The other thing is, I mean, the question about priority, that's the last thing I will say. The question about whether we should be wasting our time on climate change adaptation when we have other much more pressing problems, and when our risk tolerance is much higher than societies which don't have war, in societies that are richer, that have managed risk in a different way. One possible approach is to assess current vulnerability rather than future vulnerability to heat waves, to stormwater. In the end, we have problems with stormwater management now. We have problems with peak energy now when we have electricity cuts. All of these, there's a lot of areas of overlap between, in essence, climate change adaptation is going to exacerbate these problems. So one way to approach this thing is to say, well, which of these problems, if we try to deal with them, would actually benefit us now, regardless of whether climate change eventuates or not? I mean, that's another possibility. I think I'll stop here. I'm sorry I went vastly over time. Thank you very much. Hi. Good.
This is really fascinating. There's a lot of interesting research that was done in late 19th century, early 18th century in Australia on heat. Okay. And I think it's kind of one of these issues that probably have
been with the country for quite a while.
Throughout time.
Yeah.
And
if you go there in summer, you understand why.
Yeah, of course. And I can come back that also. Like
of course.
One of the hottest cities in the world. But one of the interesting work on the history of heat and medicine actually is by Warwick Anderson, who actually did work on Australia in like late 19th century, early 20th century, and looked at the way medicine, medical literature, medical research looked at the construction of whiteness really through the talk about heat, and how white settlers were more vulnerable to heat. And there was this whole kind of language of adaptability and adaptation, and which really was a way of, what he argues is a way of constructing what whiteness was all about.
In relation to heat.
And I'm wondering, within this kind of setting, and especially since vulnerability is becoming kind of a buzzword, not only in science, but I guess in a lot of social research and international intervention, the kind of the racial factor in not only the socioeconomic, and especially in a place like Australia where Aboriginal communities really feature so strongly, not only in the kind of the research and the kind of the anxiety of policymaking
of the white society,
but also in kind of how it becomes a way of really talking about that issue without really talking
about it.
And I wonder how much is that also, as you mentioned, the Lebanese aspect, the immigrant aspect is one other dimension that has to do with race.
Yeah.
And I'm just wondering how...
To what extent it's politically suspect, in other words, or you mean? Yeah.
No,
not necessarily.
I'm just wondering how it features in, how race is kind of...
It's a very tough question. That's the first thing. It's obviously it's a very big question, very interesting question, but very big, far too big for me. But what I would say is, first observation I would make is that race doesn't figure. It figures. It's an extremely important factor, like in all Western societies that are coming to terms with their colonial past. Australia is no exception. But it's very different. And I know that you've been back from the US not long, but it's very different to the way race plays out in the US. Why? I'm sure it's a very complex, that is question beyond me, but one way in which this happens, for example, the way the African Americans have been urbanized through industrialization. Some of the, from what I know of, some of the migrations from the south to the urban centers in the north, that hasn't happened in Australia. And in that sense, the indigenous Australian is far more marginalized, far more marginalized. Numbers to begin with, they've been practically decimated. There's 400,000 left. It's been an extremely successful colonization in that sense, reminiscent of Argentina probably. I mean, the only place I can think of, or maybe Canada too. I don't know. I don't know how many indigenous population. Which means they don't. In heat waves, the research on heat wave, they don't figure. What figures much more prominently are the migrant populations, but not because that's the paradox. You'd think the Lebanese, for example, is more adapted to heat than the white European, and I'm sure the Lebanese is more adapted to heat. And yet, in the adaptive capacity indicators, you use the percent of population not with English, not because that indicator is used as a socioeconomic indicator, and that's the Australians aren't the first to have done that. This is often used in a lot of migrant societies, a society with a lot of migrants. It is an indicator of income. I know I haven't answered your question, but the only thing I would say is it doesn't figure in the research, at least. I don't know the research, the historical research on heat, but Aborigines don't come up very often in those issues. Partly because there's very few of them. They don't tend to live in urban centres on their own. Where they live in centres is mostly in rural Australia, which is extremely hot. And I think in central Australia, where the dynamics of heat waves are so different anyway, because it's really extreme hot environment, that doesn't, as far as I'm aware, I mean, that doesn't come up. But I know there was many aspects to your question that I can't even begin to. Yes.
Just a quick follow-up on
yeah.
this. When we hear a lot about the Australian bushfires,
yeah.
I mean, when I was living there and when I came back here and I followed these events up, I rarely heard about Aborigines, indigenous Australians, dying from these.
I haven't either. That's why I was. Yeah.
So that's
it's interesting. Yeah. I don't know what the. I mean, the only thing I can think of is the numbers. It's really the numbers are small. So there's 400,000 Aboriginal Australians out of a population of 22 million. So that we're talking about, that's if it's 40 million, that would be 10%. So that's about 5%. That's about 5%. No, sorry, more. 400,000 is 10%, is 20%.
How many Aborigines now?
400,000 out of 22 million. Sorry, that's 400,000. That's 4 million. Sorry, that's 2%. I think it's 1%.
400 from 42 million.
No, from 22 million. From 22 million. So it's yeah.
But I mean, that's interesting. It's always the new migrants. I mean, historically, it's the 18th century, the kind of the whites arriving, and it's kind of they're the ones who are not, they're more vulnerable to heat, and then it's now the new immigrants.
Although no, the linkage isn't made directly to the new immigrant. No one said that the new immigrant is more vulnerable to heat. All this is saying, and it's important to make that distinction. It's a very important distinction. All this is saying is, I'm trying to find out if this community has good adaptive capacity, generally. Whether if it's under stress, whatever kind of stress, it is capable of mobilizing resources in order to fight that stress. That's all it's saying, regardless of the heat or something else. And what it said, look, it's very hard to quantify this. So the way I'm going to quantify this is look at some indicators, and one of these indicators is the percentage of migrant population, because then that's an indicator that the community is less. That's
Abbas, I'd like to go back to the, first of all, thank you, this was very enlightening. I'd like to go back to the model and then ask you to reconsider how you placed your adaptive capacity.
It's not my model, by the way. This is IPCC model. Yeah. How do you place adaptive capacity?
Because the adaptive capacity doesn't just modify the impact of exposure and sensitivity on producing vulnerability. It also impacts exposure and sensitivity.
Yeah.
So
Yeah.
the adaptive capacity starts. I mean, can
Absolutely.
determine the very first exposures that can lead then to all sorts of other things. So
Yeah.
that model has to be.
Yeah, I think that's a very good point. And you can find, this is the model that is the most widely used model in a lot of assessments. But there are other models in the literature. One of the models, for example, would recognize, sorry, by the way, I've got a list of references that I've referred to and resources. I'm aware that this is very small, so I just printed 20 copies. Anybody interested in vulnerability research is welcome to pick up. Just as a startup, some of the more interesting papers, theoretical and practical, and some of the references that I've used here. Let me go back to that. Here it is. There's a number of models in the literature, and you see some of the papers that are in the list actually produce different models. Now, because it's coming from most of the literature on vulnerability to climate change, it's really, when I showed those two schools of vulnerability, most of the literature on climate change comes from the second one, natural hazard vulnerability, which really gives primacy to the exposure and the sensitivity. So the modification that I remember coming across in different models is where you have sensitivity and adaptive capacity as a function of exposure rather than as a constant. That's one possible modification. What this recognizes is that you may have an adaptive capacity that is good for a certain level of exposure, but that might change as you have another. It might not be able to cope with higher exposure. Likewise with sensitivity. So this introduces a nonlinearity in the system whereby sensitivity is a function of exposure and adaptive capacity is a function of exposure. Another possibility is to add, one component is sometimes added, is the ability to recover from stress. Now, I haven't seen any model which, I can see exactly where you're coming from. I can see exactly why you could have a model where exposure and sensitivity depends on adaptive capacity. I think there might be, and I'm guessing here, there might be two reasons why such a model isn't displayed. The first one is because of where the theory comes from. It comes from natural hazard approaches. We've got an earthquake, which is one of the most important determinant of how people are going to react to an earthquake or how are going to be affected by the earthquake is the earthquake strength. So the models that tend to be biased towards the actual environmental stress that was the source of the problem, which, as you're saying, actually may not work well in this case. But the other reason is the issue of, so what do you do with a model like this? If you've got a dependence of adaptive capacity on exposure, how do you characterize practically this dependence? How do you go about quantifying? All people working in this area, for better or for worse, and you might decide this is a futile exercise, but for better or for worse, what they have in mind is the ability to come up with scores in the end. Some kind of quantification that would allow you to use to develop a quantitative method that would identify vulnerable population. So the question then becomes, if we did recognize that adaptive capacity, that exposure depends on adaptive, even exposure depends on adaptive capacity, how do you characterize this? And I think models are evolving. I'm sure this will look, in 5 or 10 years from now, this will look like a really blunt instrument. In fact, it's pretty unsophisticated as a model. But it is the first attempt we have now at trying to do these quantifications. Yes?
Have there been attempts to have a historical component to the idea of adaptive capacity? So I'm thinking, There's been a lot of talk about, in this region, Lebanon and Palestine, there's been a lot of talk about resilience.
Yes.
And in war-torn areas. And it sounds, to me, quite similar to the idea of
adaptive capacity. Yeah.
And since you're saying that Australia has a history of fires, I wonder if it's ever been or tried to incorporate some historical component to the measurement of adaptive.
Well, okay, the answer to your last question is no. I'm not aware of any attempts in incorporating historical, except in the studies of mortalities versus temperature. When you look at those, I'll try and remember all aspects of your question, because it's, if you look at those curves, which are really about, come on. Okay. Oh. Okay, I'll leave it like this. This is, if you think about this in terms of the vulnerability framework, that model, no matter how crude and unsophisticated it is, think about it in terms of, in that context. What this is trying to do is to assess the sensitivity. This is about sensitivity. It's saying that this is how many people die depending on the temperature. Now, when you compare cities around the world, if you put those curves for different cities around the world, there's two very important variables that the literature is full of comparisons of. One is what is called the comfort temperature, which is the temperature that produces the minimum number of deaths. Now, of course, I've put here just a fit, an Excel fit. The way you come up with the curve is you do a much more sophisticated Poisson regression to come up with these figures. So it's not just a question of fitting in. But you get the minimum comfort temperature. The other important variable is, of course, the slope of the curve as you go up, because that gives you the sensitivity of the population to an increase in temperature. Now, both of these factors, if you compare, for example, there's an interesting paper which compares southern and northern United States. And you will find almost invariably in southern United States, they have much better tolerance for heat waves. And that's historical. It's because they have developed the ability. So you look at, and it translates in a slope that is much smoother, not smooth, the word is not smooth. The slopes in the northern states, for cities in the northern states, they're usually done for cities, is steeper than the slope for southern states. And that's precisely because of, for historical reasons. Now, I haven't seen historical, I mean, the historical dimensions are included could be included in validation. So, for example, one thing they've done in this model in Sydney, they asked the question, so how do we validate? So how do we know all of this is not rubbish? They've done a few things. One of the things they've done is they've taken their vulnerability scores, the vulnerability maps, and they've taken remote sensing pictures of forest fires. And they compared the maps. And they found that it gave them a good, at a certain, so here we're talking about today's vulnerability, or historic, obviously historical vulnerability in this case. I've lost now track. You had quite a few interesting questions in there, but I'm not sure whether I've answered all of them, but yeah, sorry, yeah.
Well, I appreciate your work on modeling and all the statistics. I'm an ex-AUB professor in agriculture.
Yeah.
Now, if you look at the Gulf states, I mean, they have heat waves all the time, and they solve it by air conditioning.
Yeah.
Don't they have air conditioning in Australia?
Yeah, they do. They do. The problem with air conditioning is, it's a very good question. That's exactly what policies for adaptations are trying to avoid. Just imagine what happens in a heat wave. Everybody turns on the air conditioners. So you get suddenly, if you are living in your house and you need the air conditioner, it's fantastic. You're a happy man. If you're running the electricity utility that supplies the power, it's an absolute nightmare. It's not just a nightmare from an operational point of view, but it's also when you're designing that utility. When you design, anybody who's an engineer in here would know that when you design a utility of this kind, you don't design for average consumption. You design for peak consumption. So the higher the difference between the peak and the average, you can think of that difference as the amount of waste the society is producing. Because you're designing, it's a bit like you need this chair to carry a weight. Most of the people who sit on this chair are going to be 70 kilos. But because you know there's one person who's going to be 300 kilos, who's going to sit on this chair once in its entire lifetime, you design it to carry 300 kilos. Now, this is how utilities are designed. And the problem with individual reactions like this is that there's a cost to it. And there are much more rational and better ways of avoiding. And I haven't gone through this, and this is one of the interesting questions. What do you do about heat waves? And there are things like heat warning systems, like creating green spaces in municipalities, things like having connections to people living on their own, calling them on the day of when there's a heat wave, ensuring that people with low social capital are getting support. There's a lot of things that can be done. Apart from the fact, of course, that a lot of people don't have, not everybody lives in the Gulf. And not everybody has got the amount of money that people in the Gulf, or most people in the Gulf have. And so not everybody has got an AC. And so from the point of view of equity of the measure, you need to cater for that as well. Yes?
That was very interesting as well. And I just also wanted to get to the point that you just said.
Sorry, yeah.
Because even in the Gulf, there's people that die of the heat waves.
Okay,
and those are the people that are covered the migrant workers. So
of course.
In any context, in any society, whether we call it adaptive capacity or vulnerability, or it's going to be linked to social equity, social justice issues. So there's a lot of people that are dying in the Gulf from the sun.
Yeah. In fact, probably in a place like Dubai, it's only 30% of the population is of the resident population is, yeah.
It's a great big tower, but there's a lot of people that die.
Yeah. Thanks for that. Yeah.
Thank you very much for the presentation.
Thank you.
My name is Tariq Sadiq. I work in UNESCO. And recently I have been involved in a similar activity dealing with the water resources sector.
Okay.
The water resources sector. So I was very much interested to know what, because you said...
Of course, that's another big, very important area. Yeah.
Management and other issues related to...
Sydney Water, by the way, is going through a big exercise now in assessing the suitability of the infrastructure for climate. But sorry, go ahead, yes.
Yes. So I'm trying to apply this methodology for the whole square region, or mainly Western Asia region, all Arab countries, and using some kind of sustainable development indicators. They have been developed among the member states, and they agreed on a specific list, which is very similar to what you have done here. But
to what I've reported, it's not me who has done it, but yeah.
University. I feel the approach is still a bit static, like it's a snapshot kind of analysis.
Yeah,
like,
absolutely.
Defining some indicators, independent indicators, and then try to develop a vulnerability index on the other side.
Which is a dream for us researchers. It's an area where you could see there's still a lot to be done. Absolutely, yeah.
Because the alternative in our region is to use GCMs and RCMs and try to use some modeling.
Sorry, what is GDM and RDM? Sorry.
It's global circulation modeling.
Oh, okay, it's GCM. Yeah.
Downscaling processes.
It's not an alternative, because these models use the results of GCM. You need the results of GCM in order to be able to do this. So GCMs, all the GCMs give you is what the climate is likely to be in 20 years from now in a particular locality, but it doesn't tell you how that that climate is going to affect people. And this is what this is doing. It's translating GCM findings into impact on people. Sorry, just a minor correction. Yeah.
I like this simple approach, but how can you incorporate the time factor, the dynamics
it's very hard.
these variables in this analysis?
Yeah.
This will be a big challenge.
It's a big. Some of the more interesting things that are being done, as far as I'm aware, there's some GIS systems that are being developed where they introduce some time dimension, because I think I've pointed out that really this exercise is essentially about systematically taking maps of individual components of vulnerability, putting them together and seeing where you're getting red everywhere, in which localities, to find out which locality is vulnerable. There's obviously a strong GIS, Geographic Information System, component to it. And some of the interesting things that are being done, as I understand it, I don't know a lot about that, but there's some new GIS systems that have a stronger time dimensions where you could include that. I think the time dimension makes the question asked by Samir even more pertinent. And I think going back to my forest fire that I've used in the beginning, which I precisely wanted to use as an example of how complex it is. That's why I said if you were trying to predict back in 2000 how the forest fires are going to affect Melbourne in 2009, you have to take into account the fact that the practice of people in dealing with the fire wasn't going to work if you're successful in making that prediction. But even more complicated is if you're going to 2020, that you have to take into account that people will have had a forest fire, will have learned that this doesn't work, will have developed something else. All of this should go into your adaptive capacity in characterizing. It's very hard. So I think what I think I've shown you is what I saw in the literature as being roughly the state of the art of what's being done now, which is why it's, as you can see, it's so blunt. It's so, in some ways, so unsophisticated compared to things that people have done in other areas, which is why it's fantastic for researchers. It's a great area of research.
Abbas, if you allow me one final question. First, I'd like to mention that you mentioned that you were assuming being a magician.
Yeah.
يا ريت you are a magician, you create a clone of yourself and you send us one to FHS. Well, concerning these models, and it's a very complex, model, and as you said, it's a challenge to researchers. So probably in other parts of the world, we'd like to adopt these models and try to use them in our local context. How do you think, how easily are they extrapolated? Because I couldn't help noticing, for instance, I mean, although it's probably a bit insignificant, this indicator. One of the indicators used, for instance, in the model for socioeconomic status, and this is very particular to the Australian context, is the median home loan repayment.
Yeah.
This is something that we cannot use.
Yeah, I was amazed by that, because it's what amazed me about it is that it's very transient. I was surprised. I'm not sure. I haven't gone back and read. They've got the report is good. I can make available the link to the report. It's a good report. It's an interesting report. And they do have in the appendix a justification for every single indicator. So you could at least, even if you don't agree with the justification, you could see the rationale for why they've. I don't know why. I mean, I never had the time to go and check that particular. But it's a transient thing. I was amazed, particularly in a period where there was a lot of economic fluctuation. Home loan repayment can be, but they must have seen it. And this is where you're talking about, it's economics. To what extent home loan, you might find that home loan repayment actually are a good indicator. There's a good correlation between home loan repayment and the socioeconomic status of a community. I don't know, but yeah. It's a good point. Yeah.
The question is how adaptable you think
the answer, I think the approach, I'm sure, is adaptable, would be an interesting exercise, but which socioeconomic indicators you choose for a particular country, I think you have to be very careful about that.
I'm talking about
in other places, in other countries. Yes. Now, it's probably adaptable from Sydney to Melbourne. Whether it's adaptable from Sydney to Beirut is a different story. Well, I mean, think about it. If home loan repayment would make sense, what is the proportion of home owners, people with mortgage in the population? I don't know. I'm assuming it's not very high. And therefore, home loan repayment wouldn't tell you much. What you have to remember, this is not about the indicator. The indicator is used as a way of, the question is simply, how much resources does this community have at its disposal? And it's not even that, because this is not what the vulnerability score is telling you at the end. All it's telling you is, does this community have more resources than that community? It's not even telling you whether this community has more resources than a community in Rio de Janeiro. You can't move it, you can't, because it's all about relative strength in a particular system. Absolutely. That's what it's aiming to do. But they didn't claim that they're doing anything else. All this is telling them, this is why it's important what you use it for, all this is telling them is, if the state government of New South Wales, which is responsible for Sydney, wants to put resources in adapting to climate change, where should it put them? That's what it's doing. What it's also doing is it was sent to the municipalities, and it gave them an idea. Municipalities are hearing about climate change. Some municipalities have some resources to invest. They want to know what to do. And the process itself, not just we were talking about process earlier as opposed to the actual outcome. Here again, the process of going through all this is very useful because they did it with a lot of consultation with the municipality. It was a form of dissemination as well and education for the municipalities.
And just one final observation, because you put the Ethiopian picture, and
yes.
it was very, very interesting.
Yeah.
I was thinking about the indigenous aborigines in
yes.
Australia and about the bushfires
yes.
and them not being very much affected by that.
Yes.
Because they have this 400 million
where they conducted controlled fires apparently in their
knowledge, they avoid
very possibly.
areas that have bushfires.
Very possibly. But also they don't have as much property. As they live in much more mobile property as well. So yeah. Thank you.
Thank you, Abbas. I'd like to go back to this issue of summing up all the impacts.
Yes.
And ask you whether the research is looking at the interaction between those things. These impacts are not independent of each other.
Yeah.
The fact that most of the people in Australia live on the Dahi, because it's all of these questions that come up. And so
I think that's
separating
is very dangerous.
Lumping them together is sort of.
Well, I think lumping them together only makes sense if you're making a big assumption by lumping them together, which is you can't. Those problems are not big enough for society to be able to afford to deal with them all. The heat impact, the stormwater management, the society can't, that's the other assumption, can't make all municipalities give them money to adapt to climate change. It's very much a budgetary exercise, and it's blunt. But what I think one of the interesting things about your comment is in a sense is an answer to the transmissibility of this kind of research. What you were saying is, just by looking at the poverty areas in Beirut, you could see that not just because they're poor, but because of the housing conditions. You could make the argument more developed just because of the housing conditions. You could see that you probably you can bypass this exercise by, for example, focusing on some of the poverty areas. In other words, you don't need to do a map of municipalities that are vulnerable, because you don't if you had the data and you had a couple of researchers who are prepared to put in the time and you've got money to do it, fine. But since we don't have the data, but what's important in this, I think, then we can't do it, but what's important in this is that what you're saying means that we don't have to do this kind of maps in the context of Beirut. Perhaps maybe we should have done something different in the context of Sydney as well. Now, to go back to your original question is, I haven't seen papers that are dealing with these interactions between, I'm sure they exist. By the way, the literature on adaptation, if you go and do a search, which is what I've done, I'm trying to remember, I went to Web of Science, I think I did climate change and adaptation and vulnerability. The number of, if you look at, from memory, the number of papers in 2009 and 2010 have probably multiplied by 10 compared to the 2 years previously. It's really an exploding field. So there might well be papers that are looking at some of these interactions. I haven't come across, certainly I've read some of the fundamental theoretical literature on vulnerability. Some of the, I know reasonably well the literature on heat waves. I haven't seen anything that is looking at those interactions, possibly because the problem is so big and people are still trying to find their way around it. The other thing is adaptation. There's been much more that I should have mentioned this. If you look at agricultural sectors, if you look at water, there's been a lot more work done. What's new about this is that it's looking at vulnerability at the municipal level. I should have made that point. There has been more sophisticated work on assessment of vulnerability of agriculture, for example. And I'm sure probably Ramiz Ray would have done something on this. There's been more work on coastal, rise of coastal, the effect of rise in sea level on coastal structures. There's been work on water, the effect on water, as you're saying. This is newer. And because what you're looking at is a locality rather than, with the water, you're looking, basically your outcome is one single infrastructure and you're trying to protect it. It's simpler. Still, I'm sure, very complicated. Still, I'm sure it's got many dimensions because you're talking about multiple impacts, multiple sources of impacts. But in the end, you're looking at one number. Here, you're looking at a locality, and there's a multiplicity of the impacts. Whether people have looked at the interactions, I don't know, that would be very interesting. But, so in a sense, I talked for 5 minutes and didn't answer your question. But okay. I think, thank you. Thanks.